We have now done pyramids. You should have finished the exercise and marked it completely. So tick those off. The last bit is on cones. After that, we're going to look at problem solving. So let's start cones now. So when you're looking at a cone, it's just a circular base pyramid. So if you imagine a tetrahedron like this, the more sides the base has, so for example, there's a number of sides you can see on the top and the bottom just by visualizing it, the closer it starts to become to a cylinder, not a cylinder, a cone. So you can imagine the formula for the area of a pyramid is 1/3 base area times height. So for a cone, it's just 1/3. The base area happens to be a circle times height. So 1/3 pi r squared times height. That gives you this when you just write it out. And the area of the base is pi r squared, like I mentioned. And the area of the curved surface, now this is new. And you need to know again what this is, the formula. Pi times r times l, where l is the slant height. Now, often with problem solving questions, you will be given the height, the perpendicular height, and the radius, but when you're working the curved surface area out, you might need to use Pythagoras quite often to work out the slant height, and then you can work out the surface area of the cone part. And if you're asked to work out the surface area of the whole cone, then you have to also remember to add the base bit, which is pi r squared. So when you combine these two bits together, here and here, that will tell you the surface area of a cone. Okay, so you can make notes on that however you need to. Now, a frustum, I've been calling them frustrums for years just because it sounds more natural, but it's actually frustum, is a portion of a cone or a pyramid that's been cut off. So specifically the ones on the bottom that you see here. You're typically not going to have to worry about whether it's called a pyramidal frustum. It's just going to be called a frustum, and then you can work out what type it is from the diagram, or if you're told. So cones and frustrums, can you do the example on the bottom of your screen? And I've linked to a GeoGebra thing, which I might show you now, but try to work out the volume and surface area first. Okay, so here are the answers. So you should have done this in your books, 12 pi and 24 pi. Right, the GeoGebra link is not that exciting, so I'll link to it later in the worksheet. So a frustum is a cone with a part of the top chopped off. When you are working out the volume of a frustum, there's no formula to get the volume of a shape like this. So instead, what you do is you have to imagine that the top piece is there. You work out the volume of the whole frustum. You take away the area of the invisible bit, and then you're left with what's left, and that's what you want. So the volume of the full pyramid here is going to be 1/3 base area times 12, and the volume of the small pyramid is 1/3 base area times the height. In this case would be 3, because it's 12 minus 3, so that's the height there. And then you can just simplify it, and you end up with 63 pi. Now, this is a fairly straightforward question. What you might get is slightly harder questions, like this one here. And the thing that makes it harder is the information that you're given. So you'll notice in the previous question, you've been given the radius of the top and you've been given the radius of the bottom. That's very useful information because radius appears in the formula. For the next slide, what you'll notice is we don't have the radius, so this is the crucial bit here. And that's what we need to work out before we can work out the volume of the invisible cone at the top. So in this case, we have to use similar shapes or similar triangles. So the first triangle you'll notice, or I'm going to show you, is this one here. And you can see the height, I'm going to sketch it out on the side. The height is 2. The radius, we'll call this x. And then the second triangle, the big one, again, I'll sketch this out here. It's a similar triangle where the radius is 12 and the height is 8. Now, in this case, the scale factor k is really straightforward. You can see it's 4 times bigger or 4 times smaller, depending on which way you're going. So I can work out, I can divide by 4. I know x is 3. And then from there, you use the formula. So 1/3 base area, so it's pi times, now we want the big one first, so 12 squared. Pi r squared times height, which is 8. Take away 1/3 pi, in this case the radius is 3, we just work that out, 3 squared times 2. And then you should simplify, and I'll have the answer here for you. So just so you can check that out on your calculator. Now, have a go with this question here. We want to find the volume of the frustum that's shown in the diagram. All right, so from this, you can see there's the frustum itself, there's the full cone, and then you can see on the top the green cone there. That animation was completely useless to you. I just took a while making it. I thought it would be useful, and then it turned out it was not useful. I just can't bring myself to delete that, so I hope you enjoyed that. So we want to work out using similar shapes. First of all, I need the radius, so 7.2 is not going to be very interesting to me. So 7.2, to work out the radius, if I half that, I am going to get 36, 3.6. So in your head, you can half 72, so that's 3.6. So the big triangle, I'm just going to sketch it out here. 3.6, and then the small triangle. I know the height of the small triangle is 3.2, and the height of the big triangle is 6.4. So that's just telling me the scale factor is 2. So 3.6, I then have to divide that by 2 again to work out this length here. So 3.6 divided by 2 is going to give me 1.8. That's the radius there, or the radius here. It's the value of x. So then you just use the formula, 1/3 pi times the big one first, so 3.6 squared, times height, which is 6.4. Take away 1/3 times pi times, now the radius on the small one is 1.8 squared times the height is just 3.2. Put that in the calculator. So I have got 76.001, and you can round that to 76 centimeters cubed. I hope that is useful for you. So you are now going to do exercise 4, and I'll see you after you've done exercise 4 and marked it.